Welcome to Sleepless Philosophers, where deep ideas meet restful nights. If you enjoy these journeys through philosophy, please like and subscribe and turn on notifications for daily uploads. To support the channel, consider leaving a super thanks. Any amount helps us continue creating content. You can also become a member to request video topics. We're not monetized, so your support truly makes the difference. Now let the philosophy begin. The problem of universals. Why redness exists everywhere and nowhere. A philosopher observes that multiple objects share properties. Multiple things are red, multiple objects are round, multiple animals are cats, and this sharing, this commonality, requires explanation, requires understanding what it is for different things to have the same property. And this is the problem of universals, one of the oldest and most fundamental problems in metaphysics. The question of whether properties like redness or roundness or cathood are real entities that exist independently of particular objects, are universals that multiple particulars instantiate, or whether properties are merely names, merely words we use to group similar objects without corresponding to any real shared entity. And the problem divides philosophers into realists who accept that universals exist and nominalists who deny them, and both positions face difficulties. Both must explain how we think and talk about properties, how science discovers laws about kinds, how resemblance works, and neither position has one consensus. And the problem of universals remains one of the deepest questions in ontology, a question about the fundamental furniture of reality, about what kinds of things exist. Imagine two red objects, a red ball and a red shirt, and they share something, they are both red, and the question is what this sharing amounts to, what grounds the similarity. And the realist says both objects instantiate the same universal, the property redness, which exists as a separate entity, an abstract object that is somehow present in both particulars. And the universal redness is one thing that exists in multiple places, is wholly present in each red object. And this explains similarity, explains how multiple things can be red. They all instantiate the same universal, and the nominalist says there is no universal. There are only the particular red objects, and the similarity is primitive, is a brute fact, or is explained by resemblance. The objects resemble each other, or is explained by linguistic convention. We call both red using the same word, and redness is not a real entity, but is a feature of our language or conceptual scheme. The problem can be stated as a dilemma. Either properties are universals, abstract entities that exist independently of particulars, or properties are just features of particulars. And if properties are universals, then we face the problem of how abstract entities relate to concrete particulars, how universals are present in objects, whether they exist in Plato's realm of forms separate from physical reality or exist in objects themselves, as Aristotle thought. And if properties are just features of particulars, then we face the problem of explaining resemblance, explaining what makes multiple objects similar, what grounds classification into kinds, and neither horn is comfortable. Neither provides an obvious easy answer. And the problem of universals forces us to choose between problematic metaphysics or problematic nominalism. Visualize the realist picture, a realm of abstract universals, redness, roundness, cathood, existing eternally and independently, and particular objects participating in these universals, instantiating them, exemplifying them, and an object is red by standing in an instantiation relation to the universal redness. And this relation is mysterious, is not itself explained. How do abstract universals connect to concrete particulars? How does the abstract realm interact with the physical realm? And the realist must either accept this as primitive, as an unexplained connection, or provide a theory of instantiation. And various theories have been proposed, but all face difficulties, all struggle to explain how universals and particulars relate. One version of realism, Platonic realism, says universals exist in a separate realm, a realm of forms, and particulars participate in forms. And the perfect circle exists in the realm of forms, and physical circles approximate it, participate in it imperfectly. And this explains how we can think about perfect circles. Even though no physical object is perfectly circular, we grasp the form directly through reason, but the theory faces the problem of how we access the realm of forms, how our minds, which are physical, can connect to abstract entities, and the theory faces the problem of how participation works, how forms relate to particulars. And Aristotle rejected Platonic realism, argued that forms exist in particulars, are immanent in objects, not transcendent, and redness exists in red objects, is a component of them, and this avoids the separate realm, but creates other problems. How can one form be in many places? How can universals be divided among particulars? Nominalism rejects universals entirely, accepts only particulars, and explains similarity without appealing to shared properties. And various nominalist strategies exist. Resemblance nominalism says objects are similar because they resemble each other, and resemblance is primitive, not explained by shared properties. And redness is just the class of objects that resemble paradigm red objects. And this avoids commitment to universals but faces the problem that resemblance seems to presuppose properties, seems to require that objects share something. And if resemblance is primitive, then we have not really eliminated properties but renamed them. And resemblance nominalism faces technical difficulties with explaining degrees of resemblance, with avoiding circularity. Another nominalist approach, predicate nominalism, says properties are just predicates, just words, and redness is the predicate red, and objects are red by satisfying the predicate. And this linguistic nominalism faces the problem of explaining why predicates apply. What makes it true that an object satisfies red? And the answer seems to require properties after all, seems to presuppose that objects have features that make predicates apply, and so predicate nominalism seems to presuppose what it denies, seems to need properties to explain predication. A third nominalist approach, trope theory, accepts that properties exist but denies that they are universals, argues that properties are particulars, are individual instances, and each red object has its own individual redness, its own red trope, and tropes resemble each other. Explains similarity, and universals are eliminated, replaced by classes of resembling tropes, and this approach preserves some realist insights, accepts that properties are real, while avoiding commitment to abstract universals, and trope theory has been developed extensively, has become a major alternative to both traditional realism and nominalism, and provides a middle ground that many find attractive. The problem of universals also affects science, affects understanding what scientific laws are, because laws concern kinds, concern all electrons or all mammals, and laws seem to involve universals, seem to say that all objects instantiating a certain universal behave in certain ways, and if universals do not exist, then what are laws about? Are they merely regularities in particular objects? Are they conventions of our theorizing? And nominalists must explain how science discovers objective laws if kinds are not real, if universals do not exist. And this challenge drives some philosophers toward realism, toward accepting that kinds are real, that universals exist because science seems to require them. The red ball and red shirt share something or do not share anything, are similar by instantiating a universal or by resembling each other. And the problem of universals asks which, asks what properties are, whether they are real entities or linguistic conveniences, whether redness exists in Plato's heaven or in particular red things, or only in our conceptual scheme. And the answers divide philosophers, have divided them for millennia. And the problem remains unsolved, remains central to metaphysics, and redness exists everywhere in all red things. If realism is true, and nowhere if nominalism is true, and the problem persists, ancient and unresolved, a permanent fixture in ontology, a question about whether reality contains abstract repeatable entities, or only concrete, unrepeatable particulars, and the universal's weight, existing or not existing, and the problem endures. The rubber hand illusion, when a fake hand becomes yours. A person sits at a table, their real hand hidden from view behind a screen, and a rubber hand, a realistic prosthetic, is placed in front of them where they can see it, and the experimenter uses two paintbrushes, simultaneously stroking the hidden real hand and the visible rubber hand in synchrony. The same strokes at the same times on corresponding locations, and after several minutes, something strange happens. The person begins to feel as though the rubber hand is their hand, feels the touch sensations as coming from the rubber hand rather than from the hidden real hand, and when the experimenter threatens the rubber hand, moves a hammer toward it, as if to strike, the person flinches, shows a physiological stress response, reacts as though the rubber hand is in danger. And this is the rubber hand illusion, discovered by Botvinnik and Cohen in 1998. A phenomenon demonstrating that body ownership, the sense that a body part is yours, is not fixed but is flexible, can be manipulated, can be extended to objects that are not part of your body, and the illusion reveals that the sense of body ownership is constructed by the brain through integration of visual, tactile, and proprioceptive information. And when these signals are consistent, when vision shows a hand being touched in the same way, and at the same time as tactile signals indicate your hand is being touched, the brain infers that the seen hand is your hand, updates the body representation, and the rubber hand is incorporated into the body schema. And the rubber hand illusion has profound implications for understanding embodiment, for understanding the sense of self, for prosthetic design, and for recognizing that the boundaries of the self are not fixed but are dynamic and constructed. Imagine the subjective experience. You watch the rubber hand, see the paintbrush stroke it, and simultaneously feel strokes on your real hidden hand. And at first the rubber hand is clearly not yours, is obviously a fake, but as the synchronous stroking continues, something shifts. The rubber hand begins to feel like it could be yours, begins to feel connected, and after several minutes, the feeling is strong. The rubber hand feels like part of your body, and when you're asked to close your eyes and point to where your real hand is, your pointing is shifted toward the rubber hand. You mislocalize your real hand, place it closer to the rubber hand than it actually is, and this proprioceptive drift shows that the body representation has been updated, has incorporated the rubber hand. And the illusion is not just a belief, but is a genuine perceptual shift, a change in how your body feels and where it feels located. The rubber hand illusion demonstrates multisensory integration, shows that the brain combines information from different senses to construct a coherent representation of the body. And when visual, tactile, and proprioceptive signals are consistent, they are attributed to the same body part, and the brain updates the body schema accordingly. And the rubber hand, despite being visibly fake, is integrated because the signals are consistent. Vision and touch agree, and the brain prioritizes consistency over implausibility, treats the consistent signals as evidence of body ownership, and the illusion reveals that body ownership is not simply given by innate body knowledge, but is actively maintained through continuous multisensory integration. And the boundaries of the body are flexible, can be extended or contracted depending on sensory evidence. Visualize the body schema as a dynamic map, a neural representation of the body's configuration and boundaries. And this map is constantly updated based on sensory input, is adjusted to reflect current body state. And the rubber hand illusion shows that the map can be manipulated, can be made to include external objects, if the right sensory conditions are met. And this flexibility is adaptive, allows the body schema to incorporate tools and prosthetics, allows extension of the sense of embodiment beyond biological boundaries. And the illusion demonstrates this flexibility, shows that a rubber hand can be treated as real, can be incorporated into the body schema, can evoke proprioceptive shifts and emotional responses. The rubber hand illusion has practical applications for prosthetic design, for helping amputees incorporate artificial limbs, for creating prosthetics that feel like part of the body rather than like external tools, and understanding the conditions that produce the illusion, the need for synchronous multisensory stimulation, informs how prosthetics should provide feedback, how they should integrate visual and tactile signals. And the illusion has been used therapeutically, has been adapted to treat phantom limb pain, to help amputees resolve conflicts between visual evidence of absence and proprioceptive evidence of presence, and the techniques developed from studying the illusion have real clinical value. The illusion also has implications for understanding the self, for recognizing that the sense of body ownership is not a simple direct given but is a constructed representation, is inferred from sensory evidence, and the self, at least the bodily self, is flexible, is not fixed by biological boundaries, and this challenges naive views of the self as a simple unity, as transparently given, and supports views that the self is constructed, is a model built by the brain, and the model can be manipulated, can include or exclude body parts depending on sensory evidence. And the rubber hand illusion shows this manipulation directly, shows that body ownership can be experimentally induced for fake limbs. And this raises questions about personal identity, about what makes a body part yours, about whether ownership is determined by biological connection or by sensory integration, and the illusion suggests the latter. One variant of the rubber hand illusion uses virtual reality, uses computer-generated hands that can be manipulated more precisely than rubber hands, can change appearance, can violate physical constraints, and virtual embodiment studies have shown that people can experience ownership of virtual bodies, can incorporate digital hands into their body schema. And this has applications for VR design, for creating immersive experiences, for understanding how to make virtual avatars feel like real bodies, and the principles discovered through the rubber hand illusion extend to virtual embodiment, show that the same multisensory integration mechanisms apply, and synchronous visuotactile stimulation produces ownership of virtual limbs just as it does for rubber limbs. Another variant explores whether the illusion extends beyond hands, whether legs or whole bodies can be incorporated, and studies have shown that full body illusions are possible, that people can experience ownership of entire mannequin bodies or virtual avatars when appropriate multisensory stimulation is provided. And these full body illusions demonstrate that body ownership is global, applies to the entire body representation, and can be manipulated systematically. And the flexibility of body ownership is even greater than the rubber hand illusion alone suggests, extends to whole body reconfiguration. And this has implications for understanding disorders of body ownership, for understanding phantom limbs and body integrity identity disorder, and for developing therapeutic interventions. The rubber hand sits on the table, fake and obvious, and yet after synchronous stroking, it feels real, feels like part of the body, and the person flinches when it is threatened, responds emotionally and physiologically as though their real hand is in danger. And the illusion reveals that body ownership is constructed, is inferred from multisensory consistency, is flexible and dynamic, and the boundaries of the self are not fixed but are continuously updated based on sensory evidence. And the rubber hand illusion endures as one of the most striking demonstrations in cognitive neuroscience, a phenomenon that challenges assumptions about embodiment, that reveals the constructed nature of the bodily self, and that shows that even the most basic sense, the sense of which body parts are yours, is not simply given but is actively maintained through brain processes that can be fooled, can be manipulated, and the rubber hand becomes real, becomes incorporated, and the illusion persists. The skeptical paradox. The ancient skeptics posed a question that has haunted philosophy ever since. How can we know anything at all? How can we justify our beliefs about the external world when those beliefs rest on foundations that are themselves uncertain, when every justification requires further justification in an endless regress? And this is the skeptical paradox, the problem that knowledge seems both necessary for action and impossible to achieve, that we cannot help but believe and claim to know, yet we cannot provide the kind of justification that would ground those claims in certainty. The skeptical argument takes many forms. One of the most powerful begins with the observation that our beliefs about the external world are based on sensory experience. We believe there is a table in front of us because we see it and touch it. But sensory experience can be misleading. Illusions and hallucinations occur. Dreams feel real while we are dreaming them. And so the mere fact that we have a certain experience does not guarantee that the world is as the experience represents it. And this means that our sensory experiences underdetermine our beliefs about the world. The same experiences could be produced by a real table, by a hallucination, by a detailed dream, or by a Cartesian demon systematically deceiving us. And if we cannot rule out these skeptical scenarios, then we cannot know that the table is real. And this reasoning applies to all our beliefs about the external world. None of them are certain. All are vulnerable to skeptical doubt. The skeptic does not claim to know that we are deceived, only that we cannot know we are not deceived. And this is enough to undermine knowledge, because knowledge seems to require not just true belief, but justified true belief. And justification seems to require being able to rule out relevant alternatives. And the skeptical scenarios are relevant alternatives that we cannot rule out, at least not without begging the question, not without assuming the very thing we are trying to prove: that our senses are reliable, that the external world exists, that we are not dreaming or deceived. The skeptical paradox is that we seem to have two incompatible intuitions. On the one hand, we are convinced that we know many things, that we know there is a table in front of us, that we know we have hands, that we know the earth is round, and these beliefs seem as certain as anything could be. And on the other hand, we find the skeptical arguments compelling. We recognize that we cannot prove we are not deceived, that the possibility of systematic error cannot be ruled out by any non-circular reasoning. And so, we oscillate between certainty and doubt, between the conviction that skepticism is absurd and the recognition that we cannot refute it. Descartes attempted to escape skepticism through his method of doubt, doubting everything that could be doubted until he reached the indubitable foundation, cogito ergo sum. I think therefore I am, the one truth that even the most radical skepticism cannot undermine, because to doubt that one exists is to presuppose that there is someone doing the doubting. And from this foundation, Descartes tried to rebuild knowledge, proving the existence of God and using God's benevolence to guarantee the reliability of clear and distinct perceptions. But few philosophers have found this reconstruction convincing. The arguments for God's existence are controversial, and even if successful, they would not close the gap between subjective certainty and objective truth, between what seems clear and what actually is. Hume took skepticism more seriously, arguing that we have no rational justification for believing in causation, induction, or the existence of an external world, that these beliefs are products of custom and habit rather than reason, that we believe because we cannot help but believe, because our psychology compels us, not because we have good arguments. And Hume distinguished between philosophical skepticism, the theoretical position that knowledge is impossible, and practical certainty, the psychological inevitability of belief and action. And he suggested that we can acknowledge the force of skeptical arguments in the study while setting them aside in ordinary life. Though this division between theory and practice remains uncomfortable, a kind of intellectual schizophrenia where we admit that our beliefs are unjustified, yet continue to hold them anyway. Kant responded to Hume by arguing that skepticism rests on a mistake, the assumption that knowledge requires correspondence between our representations and things as they are in themselves, independent of our cognitive faculties, and Kant argued that this assumption is incoherent, that we can only know things as they appear to us, as structured by the forms of intuition and the categories of understanding, and that the question of how things are independently of these structures is meaningless, not answerable even in principle, and so skepticism about the external world is based on a confused demand, a demand for a kind of knowledge that is conceptually impossible, and Kant's transcendental idealism attempts to secure the objectivity of knowledge by relativizing it to the conditions of possible experience, making knowledge possible by making it more modest, more limited, no longer claiming to grasp things in themselves, but only things as they appear within the framework of human cognition. Contemporary epistemology has developed various responses to skepticism. Externalist theories argue that knowledge does not require the ability to rule out all skeptical scenarios. That knowledge requires only that beliefs be produced by reliable processes or track the truth in certain ways. And on these views we can know we have hands, even if we cannot prove we are not brains in vats. Because in the actual world, our perceptual beliefs are reliably formed, and the fact that we cannot distinguish the actual world from a skeptical scenario does not undermine knowledge as long as we are in fact in the actual world, and our beliefs are in fact reliably formed. Contextualist theories argue that the standards for knowledge vary with context, that in ordinary contexts skeptical scenarios are not relevant, and we can truly claim to know many things, while in philosophical contexts where skeptical scenarios are explicitly raised, the standards become more demanding and knowledge claims become false. And this allows us to preserve both the intuition that we know many things in everyday life, and the intuition that skeptical arguments are powerful in philosophical inquiry, by treating these as claims about knowledge in different contexts with different standards. The skeptical paradox remains unresolved. No consensus has emerged about how to respond to skeptical arguments, and different philosophers find different responses more or less satisfying depending on their broader commitments about the nature of knowledge, justification, and the mind's relationship to the world. And the paradox continues to drive epistemological theorizing, forcing philosophers to clarify what they mean by knowledge, what conditions must be met for a belief to count as knowledge, and whether the concept of knowledge we ordinarily employ is coherent or whether it contains internal tensions that cannot be fully resolved. The skeptic sits in doubt, questioning everything, unable to claim knowledge, yet unable to stop believing, and the rest of us navigate between confidence and uncertainty, acting as if we know, while acknowledging in quieter moments that our knowledge rests on foundations that are less secure than we would like, that the gap between appearance and reality cannot be fully closed, that the possibility of error cannot be eliminated, and that knowledge, if it exists at all, is more fragile and more difficult to achieve than common sense suggests. And the paradox endures, the ancient puzzle that will not die, the question that philosophy cannot answer but cannot stop asking, and we continue to believe, to claim to know, to act with confidence, while the skeptic watches and waits, reminding us that certainty is elusive, that doubt is always possible, that the foundations of knowledge are shakier than they appear. The Raven paradox, another name for the same strange logic. The paradox stands at the intersection of logic and intuition, bearing multiple names but always presenting the same fundamental puzzle. And the Raven paradox is simply another term for what Hempel called the paradox of confirmation, the same logical structure, the same counterintuitive conclusion that observing non-black non-ravens confirms the hypothesis that all ravens are black. And the paradox is named after ravens because this particular example, chosen somewhat arbitrarily, has become the standard formulation, the canonical case study in discussions of confirmation theory. And ravens serve as the perfect illustration, because the hypothesis all ravens are black is simple, clear, empirically testable, and the conclusion that red apples provide evidence for this hypothesis is maximally counterintuitive, and so the Raven paradox persists as a permanent fixture in philosophy of science, a problem that every theory of confirmation must address, a test case that separates adequate theories from inadequate ones. The paradox reveals something deep about the nature of scientific reasoning, about how we move from observations to generalizations, from data to theories, and the lesson is that confirmation cannot be understood purely formally, cannot be reduced to logical rules applied mechanically, but requires judgment, requires taking into account background knowledge, context, relevance, and the structure of inquiry, and different philosophical traditions respond differently. Bayesians appeal to prior probabilities and degrees of belief. Falsificationists focus on potential refutation rather than positive confirmation, and pragmatists emphasize the goals and methods of actual scientific practice, and each approach offers tools for handling the paradox, for explaining why ravens matter and apples do not despite the logical equivalence. And the paradox serves as a crucible, a test that theories of confirmation must pass. And many theories that seem plausible initially reveal inadequacies when confronted with the Raven paradox, fail to explain our intuitions, force counterintuitive conclusions, or require abandoning principles that seem essential to scientific reasoning. Visualize a scientist designing an experiment to test whether all ravens are black, and the scientist must decide what to observe, where to look, what data to collect, and the obvious choice is to find ravens and check their colour, to go where ravens live and observe them systematically. And no scientist would waste time observing apples or examining non-ravens, not because such observations are irrelevant in principle, but because they are inefficient, provide so little information relative to the effort required that they're not worth doing. And this practical irrelevance, this decision based on efficiency rather than logic, is what our intuitions track. And the paradox arises from confusing practical irrelevance with logical irrelevance, from thinking that because we should not observe apples in practice, apples must not provide confirmation in principle. And once we separate these two senses of relevance, the paradox loses some of its force, becomes less paradoxical, becomes a lesson about the difference between what logically confirms a hypothesis and what constitutes good scientific practice. The Raven paradox also illustrates the problem of GRU, the challenge of projectable predicates, because just as we face questions about what confirms hypotheses, we also face questions about which generalizations are legitimate, which patterns can be projected into the future. And these two problems are connected. Both involve understanding how observation relates to theory, how particular instances support general claims. And the Raven paradox is one manifestation of the broader problem of induction, the problem of justifying our inferences from observed to unobserved cases. And solving the Raven paradox completely would require solving the problem of induction, would require explaining how evidence works, how observation justifies belief. And this larger project remains incomplete, remains one of philosophy's central unsolved problems. The paradox endures because it is simple, because it uses everyday examples that everyone understands, ravens and apples and colours, and yet produces a conclusion that seems absurd, that violates common sense, and this combination makes it pedagogically powerful, makes it an excellent tool for teaching about confirmation and scientific method, for showing students that logic can lead to surprising places, that formal reasoning sometimes conflicts with intuition, and that philosophy of science is not obvious, not a matter of codifying what scientists already know, but involves genuine puzzles that require careful analysis to resolve. And the Raven paradox remains a standard topic in introductory courses, a problem that every student of philosophy of science encounters. And despite decades of discussion, despite hundreds of papers and books addressing it, the paradox retains its power to surprise, to challenge, to force recognition that confirmation is more subtle than it appears. The ravens fly, black against the sky, and somewhere a scientist notes another black raven, records it as confirming evidence, and elsewhere someone observes a red apple, and logic says this too is evidence about ravens. This too confirms the hypothesis, and the paradox persists, a challenge to our understanding of how evidence works. A puzzle that remains unsolved, not because no solutions have been proposed, but because every solution requires sacrificing some intuition, requires accepting some counterintuitive conclusion, or rejecting some seemingly obvious principle. And the paradox stands as a reminder that scientific method is not straightforward, that the relationship between theory and observation is complex, and that even basic questions about confirmation, about what counts as evidence, about how we learn from experience, remain philosophically problematic, and the Raven paradox endures. The Stadium paradox. Zeno of Elea constructed another puzzle about motion, one less famous than his other paradoxes, but perhaps more perplexing, and this is the Stadium paradox, sometimes called the moving rows paradox, a thought experiment involving 3 rows of objects moving past each other that seems to prove that half a moment equals a whole moment, that time itself is inconsistent. Imagine 3 rows of objects arranged in a stadium, each row containing the same number of objects. Let us say 4 objects in each row for simplicity, and the first row remains stationary, while the second row moves to the right and the third row moves to the left, each moving at the same speed. At the starting moment, the rows are aligned, but after 1 unit of time, the second row has moved 1 position to the right and the third row has moved 1 position to the left. And here is where the paradox emerges. From the perspective of the stationary first row, each moving row has passed 1 object, but from the perspective of the second row moving right, the third row moving left has passed 2 objects. Because the relative motion between the second and third rows is twice as fast as the motion of either row relative to the stationary row. Zeno argued that this leads to a contradiction, because if the smallest unit of time is the time it takes for one object to pass another, then relative to the first row, 1 unit of time has passed, but relative to the second row, 2 units of time have passed, as measured by how many objects of the third row have gone by. And so the same interval is both 1 unit and 2 units, half of itself and equal to itself, and time becomes incoherent. The paradox is more difficult to grasp than Zeno's other arguments, and even ancient commentators struggled to articulate exactly what the problem was supposed to be, and Aristotle's response was somewhat dismissive, pointing out that the speed of an object depends on the frame of reference, that there is no absolute motion but only motion relative to other objects, and that the time it takes to pass an object in motion is different from the time it takes to pass a stationary object, and therefore there is no contradiction, merely a confusion about relative velocities. Modern physics has vindicated Aristotle's intuition through the principle of relativity, which states that the laws of physics are the same in all inertial reference frames, and that there is no privileged stationary frame. All motion is relative, and the speed at which objects pass each other depends on the observer's frame of reference. Yet some interpreters suggest that Zeno's Stadium paradox was actually an early glimpse of the relativity of motion, an attempt to show that if motion is real, then there can be no absolute measure of speed or time, and that this was meant to support Parmenides' claim that motion is an illusion. Others argue that the paradox reveals an implicit assumption about the discrete nature of space and time, that Zeno may have been imagining space as a grid of discrete positions and time as a sequence of discrete moments, and that the paradox arises from trying to reconcile continuous motion with discrete structure, a tension that would not be fully addressed until the development of calculus and later quantum mechanics. The paradox also touches on the concept of relative velocity, the idea that the speed of one object relative to another is the sum of their individual speeds if they are moving in opposite directions, and that this is perfectly consistent even though it means different observers measure different relative speeds. In a sense, the stadium paradox is less about motion itself and more about the consistency of measurement, the question of whether time and space have absolute units, or whether all measurements are relative to the observer. And this question would not be fully answered until Einstein's theories of special and general relativity in the 20th century, which showed that time itself is not absolute, but depends on the relative motion and gravitational fields of the observer. Zeno's stadium sits quietly in the history of philosophy, overshadowed by his more famous paradoxes, yet it contains within it the seeds of ideas that would take 2,000 years to fully develop: the relativity of motion, the frame dependence of measurement, the question of whether space and time are discrete or continuous, and the paradox remains a reminder that even the simplest scenarios, 3 rows of objects moving past each other, can conceal deep questions about the nature of reality, questions that our intuitions cannot easily answer, questions that require centuries of thought and mathematics to even begin to unravel. The temporal loop paradox. Time travel narratives often stumble into a peculiar trap, one where causation forms a perfect circle with no discernible beginning, and this is the temporal loop paradox, a scenario where events cause themselves through the mechanism of time travel, creating a chain of causation that has no origin outside the loop itself. Imagine a scientist who receives a mysterious package containing detailed blueprints for a time machine, blueprints that are far beyond anything current science could produce, and the scientist follows these instructions exactly, building the machine over many years, and once it is complete they use it to travel back in time to their younger self, where they mail the very same blueprints that they received decades earlier, and so the blueprints travel from future to past in an endless cycle, created by no one, authored by no one, simply existing within the loop. The paradox is that the information has no source. It was never invented or discovered. It merely circulates through time, and the same pattern can apply to objects, people, or even entire chains of events, creating closed causal loops, where every event is both cause and effect, where nothing enters the loop from outside and nothing leaves, a self-contained system that violates the intuition that everything must have an origin, that causes must precede effects in a linear chain stretching back to some first cause. Some physicists argue that such loops are permitted by the equations of general relativity, which allow for closed time-like curves under certain exotic conditions, space-time paths that circle back on themselves so that travelling forward in time eventually brings you to your own past. And if such curves exist, then temporal loops are possible, strange but not contradictory. Others find the loops deeply troubling, a violation of the principle of sufficient reason, the idea that everything must have an explanation, that there must be a reason why the blueprints contain the information they do, but in a temporal loop, there is no reason, no explanation. The information simply is, trapped in eternal recurrence. The loop also raises questions about entropy and the second law of thermodynamics, which states that disorder always increases over time. Yet in a temporal loop, information or objects would circulate indefinitely, without decay, never accumulating errors, never losing coherence. And this seems to violate the fundamental arrow of time that thermodynamics imposes. Some theorists suggest that quantum mechanics might prevent such loops, that the probabilistic nature of quantum events would introduce small variations each time the loop repeats, causing the information to degrade over successive iterations until the loop breaks down, while others propose that consistency conditions might force the loop to be stable, that only perfectly self-consistent loops can exist, and any deviation would create contradictions that the universe does not permit. The temporal loop paradox differs from the predestination paradox in emphasis, where predestination focuses on the inevitability of events and the loss of free will. The temporal loop focuses on the absence of origins and the circular nature of causation. And both paradoxes share the unsettling feature that time travel does not change the past because the time traveller was always part of that past, their actions already woven into the fabric of history. The loop sits outside normal causation, neither created nor destroyed, neither beginning nor ending, a strange attractor in the space of possible timelines, and it forces confrontation with the question of whether the universe requires ultimate origins, whether infinite regress is possible, whether some things can simply be without explanation, and whether time is truly linear, or whether it can fold back on itself in ways that make causation circular rather than hierarchical. The temporal loop remains a staple of science fiction and a puzzle for philosophers and physicists, a scenario that feels impossible, yet may be consistent with the laws of nature, a reminder that time is stranger than common sense suggests, and that the arrow of causation we perceive, flowing from past to future, from cause to effect, may not be as fundamental as we believe, may not be the only way events can be structured, and that reality may permit loops and circles where intuition insists there should be lines. The Sorites paradox: a single grain of sand is not a heap, this much seems certain, and adding one grain of sand to something that is not a heap does not suddenly create a heap. One grain cannot make that much difference, and yet if you continue adding grains one by one, at some point you will have a heap, perhaps after 1,000 grains, perhaps 10,000, but surely 1,000,000 grains of sand piled together constitute a heap. And so somewhere in the process of adding individual grains, a heap must have come into existence, but where, after which grain? And this is the Sorites paradox, named from the Greek word for heap, a puzzle about vague predicates and the boundaries of concepts that has troubled philosophers since ancient times. The paradox can be constructed for almost any vague term. A man with a full head of hair is not bald, and removing one hair does not make a bald man. One hair cannot be the difference between bald and not bald, and yet removing hairs one by one will eventually result in baldness. Or consider a tall person. If someone is tall, then removing 1 millimeter from their height does not make them not tall. 1 millimeter is imperceptible, insignificant, and yet removing millimeters one by one will eventually result in someone who is clearly not tall. And the same pattern applies to colours, to wealth, to age, to nearly every predicate we use in ordinary language. And in each case we are forced to accept either that there is a sharp boundary, a precise number of grains or hairs or millimeters that marks the transition, which seems arbitrary and implausible, or that there is no boundary at all, which leads to the absurd conclusion that no amount of sand is a heap, no person is bald, no one is tall, because the reasoning that prevents one grain from making a difference applies equally to every grain. The paradox exposes the vagueness inherent in natural language, the fact that most of our concepts do not have sharp boundaries, but instead fade gradually from clear cases to borderline cases to clear non-cases, and this vagueness creates logical problems, because classical logic assumes that every statement is either true or false, that predicates have determinate extensions, that there is a fact of the matter about whether any given collection of sand grains is a heap, but vague predicates resist this bivalent structure, and the Sorites paradox forces us to choose between preserving classical logic and accepting sharp boundaries, or rejecting classical logic and developing new logical systems that can handle vagueness. Some philosophers bite the bullet and accept that vague predicates have sharp boundaries, that there is a precise number of hairs that separates bald from not bald, even though we do not and perhaps cannot know what that number is. And they argue that this is no more mysterious than other forms of ignorance, that epistemicism, the view that vagueness is ignorance of sharp boundaries, preserves classical logic at the cost of accepting counterintuitive, hidden thresholds. Others reject sharp boundaries and embrace many-valued logic or fuzzy logic, systems where statements can be partially true, where being a heap admits of degrees, where a collection of grains can be somewhat a heap, more of a heap than another collection, but less of a heap than a third, and truth values range continuously from 0 to 1, rather than being restricted to true and false. Still others argue that vague predicates are context sensitive, that what counts as a heap depends on the purposes and standards operative in a given context, that in some contexts a small pile might count as a heap, while in others only a large pile would, and so there is no absolute fact about heaphood, only relative facts indexed to contexts. The Sorites paradox also has practical implications. In law, where vague terms like reasonable or substantial must be applied to real cases. In medicine, where diagnoses depend on thresholds that are often vague. In ethics, where drawing lines between permissible and impermissible actions may require arbitrary boundaries that the Sorites' reasoning undermines. And in these domains, the paradox is not merely an abstract puzzle, but a genuine challenge to decision-making and judgment. The paradox remains unresolved. Philosophers continue to debate the best response, and it stands as a reminder that the concepts we use to navigate the world, the words we rely on to describe and categorize, are far less precise than we ordinarily assume, that vagueness is pervasive, that boundaries are often illusory, and that the attempt to force the fluid and gradual into the rigid and discrete, to impose the structure of classical logic on the messy reality of natural language, leads inevitably to paradox, to situations where reasoning breaks down, where every answer seems wrong, and where the heap, like so many things, resists definition. The Swampman paradox. Lightning strikes a swamp, and in that instant a man walking through the marsh is vaporized, his body reduced to scattered atoms. And by an extraordinary coincidence, the same lightning strike rearranges nearby organic matter into an exact duplicate of the man, molecule for molecule, synapse for synapse, every memory and personality trait perfectly replicated by chance. And this duplicate, called Swampman by philosopher Donald Davidson, who devised the thought experiment, opens his eyes and continues walking, unaware that anything has happened, believing himself to be the man who entered the swamp moments before. The question that follows is unsettling. Is Swampman the same person as the man who was destroyed? And if not, then what is he? Does he have thoughts, beliefs, desires? Or are his internal states merely physical patterns that resemble mental states without actually being mental states? And this paradox strikes at theories of meaning, content, and personal identity, revealing tensions between physical and historical criteria for mental properties. Davidson argued that Swampman does not have thoughts or beliefs, at least not initially, because the content of mental states depends on causal history, on how those states were formed through interaction with the environment and the linguistic community, and Swampman has no history, no past interactions, no causal connections to the world. His brain states are physically identical to the original man's, but they lack the historical grounding that gives those states their meaning. And so when Swampman seems to think about his wife, he is not actually thinking about anyone, because his internal states have no reference, no connection to the people and things they superficially resemble. This position reflects a broader externalist view in philosophy of mind, the idea that mental content is not determined solely by what is inside the head, but also by external relations, by the history of how beliefs and concepts were acquired, by the environment in which the organism evolved and learned, and so two physically identical beings could have different mental contents, or one could have mental contents while the other has none, depending on their causal histories. Others find this conclusion absurd, arguing that if Swampman is physically identical to the original man, then he must have the same mental states, that consciousness and thought supervene on physical structure, that duplicating the brain duplicates the mind, and that causal history, while perhaps relevant to the origin of mental content, is not necessary for its presence at a given moment. And so Swampman thinks and believes and desires just as the original man did. And any theory that denies this is privileging abstract historical facts over concrete present reality. The Swamp Man paradox also raises questions about personal identity. If Swamp Man is not the original man, then he is a distinct person who happens to have identical memories and personality, but those memories are false. They are not his memories because he did not live through the events they seem to record. He came into existence mere seconds ago with a fabricated past, and yet, from the inside, from Swampman's perspective, everything feels continuous and real, and he has no way of discovering the truth about his origins. And this suggests that memory and subjective continuity may be insufficient for personal identity. That being the same person requires some kind of physical or causal continuity that Swampman lacks. The paradox connects to debates about functionalism in philosophy of mind, the view that mental states are defined by their functional roles, by what they do and how they interact with other states, rather than by their physical composition or history. And functionalism seems to imply that Swampman does have mental states because his brain plays the same functional roles as the original man's brain, and yet this conflicts with externalist intuitions about content. The Swampman thought experiment has been used to explore issues in semantics, the philosophy of language, and theories of reference, showing that our ordinary assumptions about meaning and thought are more complex and fragile than they appear, that the relationship between words and world, between inner states and outer reality, is mediated by history and causation in ways that a snapshot of physical structure cannot capture. Swampman walks through the swamp, indistinguishable from the man who died, living a life that feels real, engaging in actions that seem meaningful, and yet, according to some theories, he is hollow, a zombie of sorts, a being without genuine content, without real thoughts, a perfect imitation of a person who is not quite a person, and the paradox lingers as a question about what makes mental states meaningful, what grounds reference and belief, and whether the inside of the mind is sufficient to constitute a mind, or whether minds require roots in history, connections to the world, threads of causation that link present thoughts to past experiences in ways that brute physical similarity cannot replace. The surprise examination paradox. A teacher announces to a class on Friday afternoon that there will be a surprise examination sometime during the following week, and the examination will be a surprise in the sense that the students will not know on which day it will occur until the morning of the examination itself. And this announcement seems straightforward, even cruel perhaps, but harmless from a logical standpoint. Yet one clever student raises a hand and argues that the surprise examination is impossible, that it cannot occur, and the reasoning goes as follows. The examination cannot be on Friday, because if it has not occurred by the end of Thursday, then the students will know it must be on Friday, and therefore it will not be a surprise, and if Friday is ruled out, then the examination cannot be on Thursday either, because if it has not occurred by the end of Wednesday, then the students will know it must be on Thursday, since Friday has been eliminated, and therefore it will not be a surprise. And this reasoning continues backward through the week, eliminating Wednesday, Tuesday, and Monday in turn, until the student concludes that the surprise examination cannot occur on any day of the week, that the teacher's announcement is self-contradictory, that a surprise examination is logically impossible. The class relaxes, confident in this reasoning, and then on Wednesday morning the teacher administers the examination, and the students are indeed surprised, and this outcome seems to vindicate the teacher and refute the student's argument. Yet the student's reasoning appeared sound. Each step seemed to follow logically from the previous one, and so a paradox emerges. The surprise examination both is and is not possible. The student's proof that it cannot occur is seemingly valid, yet the examination does occur and is genuinely surprising, and philosophers and logicians have puzzled over this paradox for decades, proposing various resolutions but reaching no consensus. One approach is to question what surprise means, to argue that the student's reasoning equivocates between different senses of surprise or knowledge, that ruling out Friday does not give the students the kind of knowledge that would make Thursday non-surprising, because the teacher could change plans, could decide not to give an examination at all, could be mistaken about the week. And so even if the students can deduce that the examination must be on Thursday if it occurs that week, they do not know with certainty that it will occur, and this residual uncertainty preserves the possibility of surprise. Another approach focuses on the self-referential nature of the announcement, arguing that the student's reasoning involves a kind of paradox of self-reference, similar to the liar paradox, because the teacher's announcement refers to the student's knowledge state, claiming that they will not know when the examination occurs, and the student's reasoning attempts to derive knowledge about the examination from the announcement itself, creating a loop where the truth of the announcement depends on whether the students believe it, and this loop generates instability, making it impossible to consistently assign truth values to the claims involved. Still another approach suggests that the student's backward induction reasoning is flawed, that while it is true that the examination cannot be on Friday, if the students know this in advance, the elimination of Friday does not straightforwardly imply that Thursday can also be eliminated, because the reasoning that rules out Thursday depends on the students believing that Friday is ruled out. But if the examination could in fact occur on Friday, despite the reasoning, then the entire chain of deductions collapses. And this highlights a problem with self-fulfilling or self-defeating prophecies, situations where believing a conclusion affects whether the conclusion is true. The surprise examination paradox also connects to issues in epistemic logic, the formal study of knowledge and belief. Because the paradox involves nested levels of knowledge, the teacher knows that the students do not know when the examination will occur, the students know that the teacher knows this, and so on, and reasoning about such nested knowledge structures is notoriously tricky, prone to paradoxes and fallacies, and formal epistemic logic provides tools for analysing these structures, but also reveals their complexity and the ease with which intuitive reasoning can go astray. The paradox has applications beyond the classroom, appearing in game theory and strategic reasoning, where players must reason about what other players know and believe, and where backward induction arguments, similar to the student's reasoning, are used to solve sequential games. But these arguments can lead to counterintuitive results, situations where seemingly sound reasoning produces predictions that are violated in practice, and the surprise examination paradox serves as a cautionary tale about the limits of such reasoning. The paradox also raises questions about the nature of surprise itself, whether surprise is a psychological state, a relation between expectations and events, or a logical property of statements and situations, and whether it is coherent to announce in advance that something will be surprising, because the act of announcing seems to undermine the surprise, yet in practice, surprise examinations do occur and are surprising, and so perhaps surprise is not as fragile as the student's reasoning suggests. Perhaps it is compatible with some forms of foreknowledge, with knowing that something will happen without knowing when or how. The teacher's announcement, the student's reasoning, and the actual occurrence of the examination on Wednesday form a triangle of tension, each element seemingly incompatible with the others, yet all actually occurring, and the paradox remains unresolved, a puzzle that continues to generate papers and debates, a simple scenario that conceals deep issues about knowledge, belief, time, and the logic of self-reference. And it stands as a reminder that reasoning, even careful logical reasoning, can lead us astray when the premises involve reflexive concepts, when statements refer to their own truth or to the knowledge states of those who hear them, and that the gap between theory and practice, between what logic seems to prove and what actually happens, can reveal faults in our logical frameworks, or in our understanding of concepts like knowledge and surprise, or perhaps in the very idea that logic can fully capture the complexities of situations involving human belief and expectation, and the examination comes unexpected despite the announcement, surprising despite the reasoning, and the students, shocked and unprepared, realize that the paradox is not merely abstract but painfully real, and the teacher smiles, victorious, having somehow managed to do the impossible, to give a surprise examination that was announced in advance, and yet remained a surprise, and the paradox endures, unsolved and perhaps unsolvable, a crack in the edifice of logical reasoning that no amount of analysis has yet managed to seal. The stone paradox, another way to ask if God can defeat God's self. The question appears in different forms across centuries, always pointing to the same underlying puzzle about unlimited power, and one formulation asks whether an all-powerful being can create a stone so massive that even infinite strength cannot move it. And this is the stone paradox, essentially identical to the omnipotence paradox, but focusing specifically on physical objects and physical power. And the logic is the same. Either the being can create the unmovable stone, which means there is something the being cannot do, namely move the stone, or the being cannot create the unmovable stone, which means there is something the being cannot create, and in both cases the being's power has limits. And the concept of all-powerful collapses, and this formulation emphasizes the physical, intuitive aspect of the puzzle, makes it concrete, gives it visual force, because we can imagine trying to lift a stone, imagine straining against weight, and the idea of a stone too heavy for even infinite strength captures the paradox in a visceral way that abstract formulations about logical possibility sometimes miss. Imagine the stone, vast beyond imagining, extending across space, dense with compressed matter, so heavy that it curves space-time around itself, creates gravitational wells, warps reality by its mere presence, and the being approaches, grasps the stone, applies force, and the stone does not move, remains fixed in space, immovable. And this defeat, this failure, seems to show that the being is not all-powerful, and yet the being created this stone, shaped it specifically to be unmovable. And if the being can create such a stone, then the being has a power that contradicts itself, a power to create constraints that the power itself cannot overcome. And this self-defeating power seems incoherent, seems to be no power at all. And so we are driven back to the conclusion that creating such a stone is impossible. But then the being cannot create everything imaginable, cannot create every physical object, and again, the being is not all-powerful. The stone paradox is sometimes presented as a reductio ad absurdum of the concept of omnipotence, an argument that shows omnipotence is logically impossible, that no being could have unlimited power, that power must have limits, and if omnipotence is impossible, then no being is omnipotent, not even God. And this conclusion challenges traditional theology, challenges the claim that God is all-powerful, and requires either rejecting omnipotence as a divine attribute or redefining it in a way that avoids the paradox. And theologians have generally chosen the second option, have argued that omnipotence does not mean literally unlimited power, but rather maximal power consistent with logical coherence. And this means God can do anything that is logically possible, but not things that involve contradictions. And creating an unmovable stone that one can then move is a contradiction. And so God's inability to do it is not a limitation, but a reflection of logical necessity. The stone paradox also has variants involving self-limitation, questions about whether God can limit God's own power, can voluntarily give up omnipotence, can create a situation where God is no longer all-powerful. And these questions are theologically interesting because they relate to the incarnation, to the Christian claim that God became human in Christ. And being human involves limitations, involves not being omnipotent, and so did God limit divine power when becoming incarnate? And if so, does this mean God is no longer omnipotent? And if God can limit divine power, does this show that God is not essentially omnipotent? And these questions have generated extensive theological debate about the relationship between Christ's human nature and divine nature, about whether limitations apply to God as a whole or only to the human aspect. And the stone paradox in these variants touches on central mysteries of Christology and Trinitarian theology. The paradox can also be understood as a question about necessity and possibility, about whether there are constraints that even an all-powerful being must respect. And the response that God cannot do logically impossible things is a claim that logical necessity is more fundamental than power. That even God cannot violate logic, and this has implications for metaphysics, for the question of what grounds logical truths, whether they are independent of God or created by God. And if they are independent, then there is something God does not control, something that limits divine sovereignty. And if they are created by God, then the claim that God cannot violate logic becomes the claim that God cannot do what God has decided is impossible. And this seems to restore divine sovereignty, but raises questions about whether God could have made different logical truths, could have made contradictions possible. And these questions push the limits of coherent thought. Some philosophers have argued that the stone paradox shows that power itself is incoherent as an unlimited concept, that just as there cannot be a largest possible number, because any number can be exceeded by adding one, there cannot be an unlimited power, because any supposed unlimited power can be challenged by asking whether it can create a limit to itself. And this suggests that power is always relational, always defined relative to tasks and capacities. And the idea of absolute power, power not relative to anything, is an illusion, a category mistake. And so the paradox does not refute the existence of very powerful beings, does not show that God cannot be maximally powerful within the constraints of coherence, but it does show that certain formulations of omnipotence, certain claims about unlimited power, are not logically tenable. The stone sits in conceptual space, hypothetical and impossible, and the being stands before it, and the question hangs: can the stone be created? Can it be moved? And the answer shapes theology, shapes metaphysics, shapes our understanding of what power is and what limits even ultimate power must respect. And the stone paradox remains a vivid, concrete formulation of deep abstract questions about possibility, coherence, and the boundaries of divine ability. And it stands alongside the omnipotence paradox as a permanent challenge to simplistic claims about unlimited power. A reminder that even theology must answer to logic, that concepts must cohere, and that the nature of God, if God exists, is more subtle and more constrained by reason than some believers want to admit. And the stone paradox persists, waiting in every discussion of omnipotence, ready to challenge every claim that God can do anything, pushing always toward qualification, toward clarification, toward the recognition that anything means anything logically possible, and that even divine power operates within the bounds of coherence. The St. Petersburg Paradox. A casino offers a game with a simple rule. A fair coin is flipped repeatedly until it lands tails, and the player receives a payout that depends on the number of flips. If tails appears on the first flip, the payout is $2. If tails appears on the second flip, the payout is $4. If on the third flip, $8, and so on, doubling with each additional flip. And the question posed by the mathematician Daniel Bernoulli in 1738 is this: how much should a rational person be willing to pay this game? What is the fair price for a ticket? And the expected value calculation gives a shocking answer. The expected value is infinite, because the probability of tails appearing on the first flip is 1/2, and the payout is $2, contributing $1 to the expected value. And the probability of tails appearing on the second flip is 1/4, and the payout is $4, contributing another $1. And this pattern continues forever, each outcome contributing $1 to the expected value. And since there are infinitely many outcomes, the expected value is infinite, and yet no reasonable person would pay a large sum to play this game, let alone an infinite amount. And this gap between the infinite expected value and the finite amount people are actually willing to pay is the St. Petersburg paradox, a puzzle that challenged the theory that rational agents maximize expected value and led to the development of expected utility theory and the concept of diminishing marginal utility. The paradox reveals that expected value, calculated as the sum of each outcome's value multiplied by its probability, may not be the appropriate guide for decision-making, because expected value treats dollars linearly, assumes that $10 is worth exactly 10 times as much as $1, and that $1 million is worth exactly 1 million times as much. But this does not capture how people actually value money. For most people, the value of money exhibits diminishing marginal utility. The first dollar is worth more in terms of welfare than the second dollar, which is worth more than the third, and so on. And $1 million does not provide 1 million times as much satisfaction as $1. And when utility, rather than dollar value, is used to calculate expectations, the St. Petersburg paradox can be resolved. Because even though the dollar payouts grow without bound, the utility of those payouts may converge to a finite value, and so the expected utility of the game is finite. And a rational agent should be willing to pay at most that finite expected utility to play. Daniel Bernoulli proposed that utility is logarithmic in wealth, that the utility of having X dollars is proportional to the logarithm of X. And under this assumption, the expected utility of the St. Petersburg game is finite, and the fair price to play is modest, a few dollars perhaps, in line with what people are actually willing to pay. And this resolution saved the principle of expected utility maximization, showing that the paradox arises not from a flaw in decision theory, but from using the wrong measure of value, from confusing money with utility. And Bernoulli's insight laid the groundwork for modern economics and decision theory, which routinely assume that utility is concave in wealth, that people are risk-averse, that they prefer a certain outcome to a gamble with the same expected value, and that this risk aversion reflects diminishing marginal utility. But the St. Petersburg paradox has deeper layers, because even the expected utility resolution can be challenged. Mathematicians have constructed super St. Petersburg games where the payouts grow so rapidly that expected utility is also infinite, even under logarithmic utility or any concave utility function. For instance, if the payout on flip n is not 2 to the power of n dollars, but 2 to the power of 2 to the power of n, or some even faster growing function, then expected utility under any reasonable utility function will be infinite. And so the paradox reappears, and this suggests that the problem is not merely about the choice of value function, but about how to handle infinite or unbounded expectations. And some decision theorists argue that games with infinite expected value or utility are ill-defined, that they fall outside the domain of expected utility theory, that the theory was never meant to handle such cases and should not be faulted for failing to do so. Others propose alternative decision theories, bounded utility functions where utility approaches a maximum, as wealth increases so that no payout, however large, has infinite utility, and under such functions, all expected utilities are finite. And the paradox is avoided, or they propose maximum principles where the agent focuses on the worst possible outcome, or they appeal to considerations of probability and belief, arguing that rational agents should not assign positive probability to arbitrarily unlikely events, that there is some threshold below which probabilities are treated as zero, and this truncation of the probability distribution renders expected values finite. The paradox also raises questions about the feasibility of the game, because no casino could actually pay out arbitrarily large sums. The maximum payout is limited by the casino's resources, and once this limit is imposed, the expected value becomes finite, and the paradox dissolves. But this response feels unsatisfying, like avoiding the problem rather than solving it, because the paradox is meant to be a thought experiment about rational decision-making, not a practical question about casino economics. And thought experiments should not be dismissed simply because they involve idealizations. The St. Petersburg paradox connects to debates about rationality and the nature of value, about whether rationality requires maximizing expected utility or whether other principles should guide decision-making, about whether value is unbounded or whether there are limits to how much anything can be worth, about how to handle uncertainty and risk, especially when probabilities are very small and payoffs are very large. And these questions have implications far beyond gambling, for insurance, for investment, for policy decisions involving catastrophic risks like pandemics or asteroid impacts, where the probabilities are tiny, but the potential costs or benefits are enormous. And the paradox shows that expected value reasoning can give counterintuitive or unhelpful guidance in such cases, that we may need other frameworks, other ways of thinking about decision-making under extreme uncertainty. The coin is flipped, tails appears eventually, the game ends, the payout is made, and the player receives some finite amount, usually small, rarely large, almost never enormous, and the expected value calculated before the game began was infinite. But this infinity is never realized, never paid out, never experienced, and so the paradox asks whether infinite expected value is meaningful, whether it should guide decisions, whether a rational agent should treat an infinite expectation differently from a very large finite one. And the answers are not obvious, not settled, not agreed upon, and the St. Petersburg paradox remains a puzzle, a test case for decision theory, a challenge to the principle of expected value maximization, a reminder that infinity is strange, that unbounded sequences create problems, that mathematical idealizations can clash with practical intuitions, and that the gap between theory and behavior, between what agents should do according to formal models and what they actually do, reveals something important about the limits of rationality, the role of psychology, the nature of value, and the difficulty of making decisions in a world where outcomes can vary wildly, where probabilities can be minuscule, and where the mathematics of expectation, taken to its logical extreme, produces results that seem absurd, untenable, impossible to act on, and the paradox endures, studied in classrooms, debated in journals, unresolved despite centuries of attention, a permanent fixture in the philosophy of probability, economics, and decision theory. The symbol grounding problem. Why computers never know what words really mean. A computer system is given a dictionary, a complete dictionary that defines every word in terms of other words, and the system can look up any word, follow the chains of definitions, process the relationships between symbols, and the system appears to understand language, can answer questions by manipulating symbols according to rules, can translate between languages by mapping symbols to symbols, can even generate coherent text by following patterns learned from training data. And yet philosopher Stephen Harnad asks a crucial question. Does the system understand what any symbol means? Does it know what the words refer to? Or is it merely shuffling meaningless tokens according to syntactic rules? And this is the symbol grounding problem. The question of how symbols, whether in computers or in minds, acquire meaning, how they connect to the world, how they come to be about something rather than being mere formal marks. And the problem challenges purely symbolic theories of cognition, challenges the idea that thinking is symbol manipulation, and points to the need for grounding, for connecting symbols to non-symbolic experiences, to perceptions and actions, to interactions with the world that give symbols their meaning. Imagine looking up the word zebra in the dictionary, and the dictionary says a zebra is a striped equine mammal, and you look up striped and find marked with parallel bands, and you look up equine and find relating to horses, and you look up mammal and find warm-blooded vertebrate animal, and you can continue this process indefinitely, following chains of definitions, symbol to symbol to symbol. And if you have never seen a zebra, never encountered stripes or horses or animals, then all these definitions are empty, are just more words whose meanings you do not grasp, and the whole dictionary becomes a closed system of symbols referring to other symbols with no connection to reality. And this is the situation of a purely symbolic computer system. It has access to definitions, to relationships between symbols, but it has no grounding, no connection to the real zebras and stripes and horses that the symbols are supposed to be about. The symbol grounding problem challenges strong AI, the claim that implementing the right program, manipulating symbols according to the right rules, is sufficient for understanding, is sufficient for genuine cognition, and Harnad argues that symbol manipulation alone is not enough, that understanding requires grounding, requires that at least some symbols be connected to non-symbolic experiences, to sensory inputs and motor outputs, to perceptions of the world and actions in the world, and these grounded symbols can then give meaning to other symbols through their relationships. And a hybrid system, with both grounded and symbolic components, can achieve genuine understanding, but a purely symbolic system cannot. Remains forever trapped in a web of meaningless symbols, playing symbol games without comprehension. Visualize two systems. One is a person who has seen zebras, has perceived their stripes, has distinguished them from horses, and when this person uses the word zebra, it is grounded in these experiences, refers to real animals encountered in the world. And the other system is a computer that has only manipulated symbols, has processed text containing the word zebra, has learned statistical patterns, but has never perceived a zebra, never interacted with one. And when this system uses zebra, it is ungrounded, refers to nothing beyond other symbols. And Harnad's claim is that these two uses are fundamentally different, that the person understands what zebra means, and the computer does not. And the difference is grounding, is connection to non-symbolic reality. The symbol grounding problem connects to arguments in philosophy of mind, like Searle's Chinese room, which argues that syntax is not sufficient for semantics, that manipulating symbols, according to rules, does not produce understanding, and both arguments challenge computational theories of mind, challenge the idea that cognition is just symbol manipulation, and both point to the need for something more, something beyond symbols. Though they disagree about what that something is, Searle appeals to intrinsic intentionality and consciousness, while Harnad appeals to sensoromotor grounding and interaction with the world. One response to the symbol grounding problem accepts it and argues that AI systems need embodiment, need sensors and actuators, need to interact with the physical world, and recent developments in robotics and embodied AI pursue this approach, creating systems that learn through perception and action, that ground their symbols in sensory experience. And these systems can associate words with visual features, can learn that zebra refers to things with certain visible properties, and this grounding, even if limited compared to human grounding, provides a foundation for meaning that purely symbolic systems lack. Another response challenges the problem, argues that grounding is not necessary for meaning, that symbol systems can have meaningful representations through their functional roles, through how symbols are used in inference and reasoning, and meaning is holistic, depends on the entire network of symbols and their relationships. And a sufficiently complex symbolic system can have meaningful representations even without grounding in perception and action. And this response defends computationalism, defends the idea that cognition is symbol manipulation, and denies that something extra, something beyond symbols, is needed for genuine understanding. A third response distinguishes between different kinds of meaning, between dictionary meaning, which can be captured symbolically, and grounded meaning, which requires connection to experience, and argues that both kinds exist. Both are legitimate, and purely symbolic systems can have dictionary meaning even if they lack grounded meaning, and for many purposes dictionary meaning is sufficient, is all that is needed for tasks like translation or information retrieval, and so the symbol grounding problem, while real, is less threatening than it appears, shows limits on what purely symbolic systems can do, but does not show that such systems are meaningless or useless. The symbol grounding problem also has implications for language learning, for understanding how children acquire meaning, because children do not learn language from dictionaries, do not master symbols by relating them to other symbols, but learn by associating words with experiences, by hearing zebra while seeing zebras, by using words in context, by grounding language in perception and action. And this grounding happens early, provides a foundation of basic concepts, and more abstract concepts are built on this foundation through symbol-symbol relationships. And so human language combines grounding and symbolic structure, uses both perceptual and abstract meaning, and neither alone is sufficient. The computer processes text, generates responses, manipulates symbols with impressive fluency, and yet the question remains whether it understands anything, whether its symbols mean anything beyond their formal relationships, and Harnad's symbol grounding problem suggests not, suggests that without grounding in non-symbolic experience, the symbols are empty, are syntactic objects without semantic content. And the problem persists as a challenge to AI, as a question about what would be needed for machines to genuinely understand, whether symbol manipulation supplemented with machine learning is enough, or whether something else, something like embodied interaction with the world, is necessary. And the problem remains unresolved, remains debated, remains a permanent feature of discussions about AI and cognition, about meaning and understanding, about the relationship between symbols and what they represent. And the symbol grounding problem endures as a reminder that meaning is not just a matter of relationships between symbols, but requires connection to a non-symbolic ground, requires that symbols hook onto the world, requires that language touch reality, and whether computers can achieve this grounding, whether they can move beyond symbol manipulation to genuine understanding, remains one of the central questions in artificial intelligence and philosophy of mind. The split brain paradox. When one person becomes two, a patient suffers from severe epilepsy, seizures that cannot be controlled by medication, seizures that spread across the brain, causing disability and danger. And as a last resort, surgeons perform a procedure called corpus callosotomy, severing the corpus callosum, the massive bundle of nerve fibers that connects the left and right hemispheres of the brain. And this procedure prevents seizures from spreading, confines them to one hemisphere, and after surgery the patient seems normal, speaks and acts as before, personality intact, memories preserved, and casual observation reveals no deficit. But careful testing reveals something extraordinary, something deeply strange. The two hemispheres have been separated, are processing information independently, are operating as two separate cognitive systems. And in certain experimental conditions, the hemispheres appear to have different perceptions, different knowledge, different intentions, and the patient, who was one person with one unified consciousness before surgery, now seems to be two persons, two separate centers of awareness inhabiting a single body. And this is the split brain paradox, a puzzle about personal identity, about the unity of consciousness, about whether consciousness is divisible, and about what counts as a person. And the phenomenon, discovered and studied extensively by Roger Sperry and Michael Gazzaniga, challenges our assumptions about the self, about the unity of the mind, and about whether consciousness is necessarily singular or could be plural within a single brain. Imagine the split brain setup. The patient sits before a screen, and images are flashed briefly to either the left or right visual field, and because of how vision is organized, the left visual field projects to the right hemisphere and the right visual field to the left hemisphere. And normally, the hemispheres communicate through the corpus callosum, sharing information. But in split-brain patients, this communication is severed, and information presented to one hemisphere is not available to the other, and the left hemisphere, which controls language, can report what it sees, but the right hemisphere, which typically lacks language, cannot speak. And this creates dissociations, cases where the person can verbally report seeing something flash to the right visual field, processed by the left hemisphere, but denies seeing anything flash to the left visual field, processed by the right hemisphere, and yet the right hemisphere clearly saw the stimulus. Because when asked to point with the left hand, controlled by the right hemisphere, the patient points accurately. And so the patient both saw and did not see, both knows and does not know, depending on which hemisphere is asked. And the unity of consciousness seems to break down, seems to split into two separate streams. The paradox becomes even more dramatic in cases of conflicting intentions, where experimenters present different instructions to each hemisphere, and the left hand, controlled by the right hemisphere, performs one action while the right hand, controlled by the left hemisphere, performs another, and sometimes the hands conflict. One hand buttoning a shirt while the other unbuttons it, one hand reaching for an object while the other pushes it away, and the patient reports frustration, reports feeling as if the left hand has a mind of its own, is acting independently, and the verbal left hemisphere confabulates explanations, invents reasons for the left hand's actions, reasons that are false because the left hemisphere does not know what the right hemisphere is doing, does not have access to its intentions. And these cases suggest that split-brain patients are not one person, but two persons. Two separate conscious agents inhabiting one body, each with their own perceptions, their own knowledge, their own goals, and the philosophical question is whether this is correct, whether splitting the brain splits the person, whether consciousness is divisible, whether personal identity can survive such division. Visualize consciousness before and after the surgery. Before surgery, there is one unified consciousness, one stream of awareness, experiences from both hemispheres integrated, and after surgery, this unity is broken. Each hemisphere processes information separately, and the question is whether there are now two consciousnesses, two subjects of experience, or whether there is still one consciousness that has become disconnected from some information, and different philosophers give different answers. Some argue that split-brain patients become two persons, that severing the corpus callosum creates two centers of consciousness, where there was one, and others argue that the patient remains one person, but with a divided consciousness, a consciousness that is no longer unified. And still others argue that consciousness remains unified, but access to information is divided, and the hemispheres are like modules within one consciousness rather than separate consciousnesses. The split-brain paradox raises questions about the relationship between unity and consciousness, about whether consciousness is essentially unified or whether it could be divided or plural. And normal consciousness feels unified, feels like there is one subject experiencing everything, one perspective from which the world is viewed, and split-brain cases challenge this unity, suggest that consciousness could be less unified than it seems, could be divided into separate streams that normally communicate but could operate independently. And this has implications for understanding the self, for whether the self is a unified entity or a collection of parts, for whether personal identity requires unity of consciousness or could survive division. One response to the paradox denies that split-brain patients become two persons, argues that the left hemisphere, the language-dominant hemisphere, is the person, is the locus of consciousness and self-awareness, and the right hemisphere, while capable of processing information and guiding behavior, lacks the higher-order thought and self-awareness that constitute personhood. And so the patient remains one person, the left hemisphere person, and the right hemisphere is more like an unconscious module that influences behavior without being a separate conscious agent. And this response preserves the singularity of persons, but at the cost of denying consciousness to the right hemisphere. Another response accepts that split-brain patients become two persons, accepts that there are two centers of consciousness after surgery, two subjects of experience, and argues that personal identity is not preserved through brain bisection, that splitting the brain creates two persons from one, and these two persons share a body, share a past, but are distinct in the present, have different experiences, different knowledge, and this response takes the split brain evidence seriously, treats the hemispheres as separate conscious systems, but faces the challenge of explaining how two persons can inhabit one body, how they coordinate, and whether one has priority over the other. A third response appeals to degrees of unity, argues that consciousness is not all or nothing unified, but comes in degrees, and split-brain patients have less unified consciousness than normal people, but are not completely divided, are somewhere between one person and two, and unity of consciousness is a spectrum, and split-brain patients are toward the divided end. And this response avoids the binary choice between one person and two, allows for partial division, for consciousness that is neither fully unified nor fully separate. And this seems to fit the evidence better, fits the fact that split-brain patients seem mostly normal, seem like one person most of the time, but show signs of division in specific experimental conditions. The split-brain paradox also connects to debates about personal identity over time, about what makes you the same person you were yesterday, about whether personal identity requires psychological continuity, and split-brain cases are like thought experiments about fission made real, are actual cases where one person seems to become two, and philosophers have long debated fission cases, cases where a person's brain is divided and placed in two bodies, and asked whether the original person survives, and if so, which resulting person is the original. And split-brain surgery is a partial realization of this scenario, does not create two separate bodies, but does create two separate information processing systems, and the philosophical puzzles about fission apply to split-brain cases, puzzles about identity, about survival, about what matters in personal existence. The patient lives with split brain, navigates the world, seems normal to observers, and most of the time, the two hemispheres cooperate through shared subcortical structures, through behavioral coordination, through learned patterns, and the division is not apparent. But in the laboratory, under controlled conditions, the split emerges. The two hemispheres reveal their independence, and the paradox appears: one person or two, unified or divided, single consciousness or dual, and the answer remains disputed, remains unclear, and the split-brain paradox endures as one of the most fascinating and philosophically significant phenomena in neuroscience, a real-world case that challenges our understanding of consciousness, of unity, of personal identity, and of what it means to be one person rather than many. And the severed corpus callosum sits there, two hemispheres separated, and the question persists: is this one mind or two? And the paradox remains unsolved, perhaps unsolvable, a permanent puzzle about the nature of self and consciousness. The Sleeping Beauty problem. A woman volunteers for an unusual experiment in probability and subjective credence, an experiment that will test how she should reason about her own situation when her memory has been manipulated. And the setup is as follows. On Sunday she's put to sleep, and a fair coin is flipped. If the coin lands heads, she is awakened on Monday, interviewed briefly, and then the experiment ends. But if the coin lands tails, she is awakened on Monday, interviewed, given a drug that erases her memory of the Monday awakening, put back to sleep, awakened again on Tuesday, interviewed again, and then the experiment ends. And the crucial feature is that whenever she is awakened, she cannot tell whether it is Monday or Tuesday, cannot tell whether the coin landed heads or tails. She knows only that she is awake and being interviewed. And the question posed to philosophers and decision theorists is this: when Sleeping Beauty is awakened and interviewed, What should her credence be that the coin landed heads? What probability should she assign to heads given her situation and her knowledge? The problem divides respondents into two camps, the halfers and the thirders, and each position has compelling arguments. Yet they reach opposite conclusions, creating a paradox that reveals deep tensions in how we think about probability, information, and self-locating belief. The halfers argue that Sleeping Beauty should maintain her prior credence of 1/2, because the coin is fair and nothing she learns upon awakening provides evidence about how it landed. She knew before the experiment that she would be awakened at least once, and being awakened is guaranteed regardless of the coin outcome, and so the awakening provides no new information, no reason to update her probability, and therefore she should stick with 1/2. And this reasoning seems straightforward, seems to respect the principle that probabilities should only change when new evidence is acquired, and being awakened is not new evidence because it was certain to happen. The thirders argue that Sleeping Beauty should assign credence 1/3 to heads, because there are 3 possible awakening situations: heads Monday, tails Monday, and tails Tuesday. And from her perspective, upon awakening, these 3 situations are indistinguishable. She cannot tell which one she is in, and by a principle of indifference among indistinguishable possibilities, she should assign equal probability to each, 1/3 to each. And since heads corresponds to only one of these situations, heads Monday, while tails corresponds to 2, tails Monday, and tails Tuesday, her credence in heads should be 1/3, and her credence in tails should be 2/3. And this reasoning seems to respect the information that if the coin landed tails, she is twice as likely to be awakened, that her current awakening is more probable under tails than under heads. And this should shift her credence toward tails. The disagreement between halfers and thirders reflects a deeper question about what credences represent and how they should be updated. Halfers tend to interpret credence as tracking objective chance, the physical probability of the coin flip, which is 1/2 and does not change based on Sleeping Beauty's subjective situation, while thirders interpret credence as tracking epistemic probability, the rational degree of belief given all available information, including self-locating information. And from this perspective, Sleeping Beauty's situation upon awakening is evidence that favours tails, because tails generates more awakenings and therefore more situations in which she finds herself awakened and uncertain. The problem becomes more vivid when decision-theoretic stakes are introduced. Suppose Sleeping Beauty is offered a bet each time she is awakened, a bet that pays if heads and costs if tails, and she must decide whether to accept. And now the question is what odds she should demand to make the bet fair, and halfers say she should demand even odds, 1-1, because the coin is fair, while thirders say she should demand 2-1 odds in favour of tails, because she is more likely to be betting in a tails scenario where she will lose. And when the bet is actually offered and payoffs are calculated, the thirder strategy performs better, winning more money on average. And this seems to vindicate the thirder position, to show that 1/3 is the correct credence for guiding decisions. Yet halfers respond that this merely shows a difference between epistemic credence and decision-making strategy, that the correct probability of heads is still 1/2, even if the correct betting strategy involves different odds. The Sleeping Beauty problem also raises questions about the reference class problem, the question of which group of situations Sleeping Beauty should consider herself a random member of. Should she think of herself as randomly selected from the set of coin flips, in which case heads and tails are equally likely, or should she think of herself as randomly selected from the set of awakening events, in which case tails is twice as likely, and different reference classes lead to different probabilities, and there is no obviously correct way to choose between them. The problem connects to issues about personal identity and indexical information, information about who or when or where you are, because Sleeping Beauty, upon awakening, does not learn any new didicto information, any new information about how the world is. She already knew that she would be awakened at least once, but she does gain new Desi information. New information about which temporal slice of herself she currently is. New information about her location in time. And the question is whether this indexical information should change her credences, whether learning that you're currently experiencing an awakening provides evidence about the coin, even if you knew that you would experience at least one awakening. Some philosophers propose middle positions, arguing that different notions of probability are at play, and that the halfa and third answers are both correct relative to different interpretive frameworks, or that the question is underspecified and cannot be answered without further stipulations about what is being asked. But these conciliatory approaches satisfy neither halfas nor thirders, each of whom believes their answer is the uniquely correct one. The problem has spawned an enormous literature, with variants and extensions testing different aspects of the puzzle, versions with different probabilities for the coin, versions with different numbers of awakenings, versions where Sleeping Beauty is told what day it is, and each variant sharpens the intuitions or reveals new complications, and the debate shows no signs of resolution. Conferences are held, papers are written, arguments are refined, and the community remains divided. And this persistence suggests that the Sleeping Beauty problem may not have a single correct answer, may instead reveal an ambiguity or indeterminacy in the concept of rational credence, a place where our intuitions pull in different directions, and no amount of formalization fully captures what is at stake. Sleeping Beauty lies in the laboratory, awakened and interviewed, uncertain whether it is Monday or Tuesday, uncertain whether the coin landed heads or tails, and she must assign a probability, must decide what to believe. And the philosophers watching cannot agree on what she should say, cannot agree on whether her credence should be 1/2 or 1/3, and the experiment continues. The coin is flipped again and again. Sleeping Beauty is awakened and interviewed again and again, and the paradox persists, a puzzle that seems simple, a question about a coin flip and some awakenings, yet contains within it deep disagreements about probability, evidence, identity, and the nature of rational belief. And no solution has won consensus, no argument has settled the debate, and Sleeping Beauty remains caught between halfas and thirders, between two ways of understanding her situation, two ways of reasoning about uncertainty, and perhaps there is no fact of the matter, no correct answer, only different frameworks that give different results. And the choice between them reflects philosophical commitments rather than mathematical necessity, and the problem endures, a touchstone in debates about probability, a puzzle that refuses to be solved, a question that generates endless discussion, yet no agreement, and Sleeping Beauty wakes and wonders, and assigns her credence, and the debate continues, without end, without resolution, a permanent fixture in the landscape of philosophical paradoxes. The third man argument, why Plato's theory spawns infinite forms. A philosopher named Aristotle attacks his teacher, Plato's theory of forms, attacks the idea that universal properties like tallness or humanity exist as perfect eternal forms in a separate realm, and Aristotle constructs a devastating objection, an argument that shows Plato's theory generates an infinite regress, creates an endless multiplication of forms, and the argument is called the third man argument, named after an example involving men, and the argument goes as follows. Plato says that multiple tall men are tall because they participate in the form of tallness. They resemble the form. They share something with the eternal perfect tall. And now Aristotle asks, if multiple men and the form of man are all men, in some sense, then what explains their similarity? What makes them all instances of manhood? And Plato's theory requires positing another form, a second form of man that the first form and the particular men all participate in, and this second form explains why the first form and the particulars are all men. But now we have the second form, and the particular men, and the first form, and these are all men, and what explains their similarity, and Plato's theory requires a third form, a third man, and this generates infinite regress, infinite forms, and the explanation never grounds, never stops, never reaches a final form that explains all similarity. And this is the third man argument, a reductio ad absurdum of Plato's theory of forms, showing that the theory is self-defeating, generates infinite regress, and cannot explain what it was designed to explain. Imagine the structure. Multiple particular tall men exist. Call them Tom and Tim and Ted, and they are all tall, and Plato explains this by saying they all participate in the form of tallness. Call it Form 1, and Form 1 is the perfect tall, is what makes Tom and Tim and Ted tall, and they are tall by resembling Form 1. But now notice that Tom and Tim and Ted and Form 1 are all tall, all share the property of tallness, and by Plato's own reasoning this similarity requires explanation, requires a form that they all participate in. And so we need Form 2, a second form of tallness that explains why Form 1 and the particular men are all tall. And now we have Form 1 and Form 2 and the particular men, all tall. And this similarity requires explanation, requires Form 3. And the regress continues infinitely. And tallness is not explained by a single form, but by an infinite hierarchy of forms. And this infinite hierarchy is vicious, is problematic, because each form was supposed to explain similarity, was supposed to ground the property, but the grounding never completes, requires further forms endlessly. The third man argument reveals a deep problem with Plato's theory. The problem is that forms are supposed to explain why particulars have properties, but forms themselves have properties. The form of tallness is tall, the form of beauty is beautiful. And if forms have the properties they explain, then they fall under their own domain, are subject to the same explanation they provide. And this creates regress, creates the need for higher order forms. And the regress is vicious because it undermines the explanatory role of forms, shows that forms do not actually explain anything, do not provide ultimate ground. And Aristotle uses this argument to reject Plato's separate forms, to argue that forms must exist in particulars, not in a separate realm, and that resemblance is primitive, not explained by participation in forms. Visualize the regress as a ladder. At the bottom are particular tall men. At the next rung is Form 1 that explains their tallness. At the next rung is Form 2 that explains why Form 1 and the men are all tall. At the next rung is Form 3, and the ladder extends infinitely upward, never reaching a final rung, never grounding the explanation. And climbing the ladder does not bring us closer to understanding tallness, only pushes the question higher. And the third man argument shows that Plato's theory is a ladder to nowhere, is an explanatory structure that generates infinite regress rather than providing genuine explanation. One response to the third man argument, a response Plato himself may have considered, denies that forms have the properties they explain, denies that the form of tallness is itself tall, argues that forms are paradigms, are perfect standards, but do not instantiate the properties they ground. And the form of tallness is not tall, but is what tallness is the nature of tallness. And particulars are tall by resembling the form, but the form does not resemble itself, does not participate in itself. And this blocks the regress because there is no need to explain why the form and the particulars are both tall. The form is not tall, and only particulars are tall, and the regress does not start. And this response requires distinguishing between being a property and instantiating a property, requires that forms be properties without having properties. And this is metaphysically subtle, requires careful formulation. Another response accepts that forms instantiate themselves, accepts that the form of tallness is tall, but denies that this requires further explanation, denies that the form and particulars being tall needs to be explained by a higher form, argues that the form is self-explanatory, is the ground of tallness, and the fact that the form is tall is not a further fact requiring explanation, but is constitutive of what the form is, and this response blocks the regress by denying the premise that all similarity requires explanation, allows that some similarity is primitive, is not explained by further forms, and the form of tallness being tall is primitive, grounds other tallness, but does not itself need grounding. A third response from Aristotle's own position rejects Plato's separate forms entirely, argues that universals exist in particulars not in a separate realm, and tallness exists in tall men, is immanent, not transcendent. And this avoids the third man regress because there is no separate form that is itself tall. Forms are not separate entities but are aspects of particulars, and the regress does not arise because there is no form that shares the property with particulars. And Aristotle's immanent realism avoids the third man argument by changing the metaphysical location of universals, putting them in the world rather than in a separate realm. The third man argument has influenced debates about universals throughout history, has been revived and refined, has been applied to various theories of properties, and the argument shows that any theory that posits entities to explain resemblance must be careful not to make those entities instances of what they explain, must avoid the structure that generates regress, and modern theories of properties, trope theories, and resemblance nominalism and immanent realism all have been shaped by the need to avoid the third man regress. All have been designed to explain properties without generating infinite hierarchies. The argument also appears in discussions of sets and classes, because Russell's paradox is structurally similar, asks whether the set of all sets that do not contain themselves contains itself, and generates contradiction, and avoiding Russell's paradox requires type theory or other restrictions that prevent sets from being members of themselves, and these restrictions are analogous to the restrictions needed to avoid the third man argument, are ways of preventing entities from falling under their own domain, and both paradoxes show that self-reference creates problems, creates regress or contradiction, and metaphysical theories must be structured to avoid self-application. Plato's forms stand in the realm of perfect ideas, tall and beautiful and just, and the particular men stand in the physical world, tall by participation in forms, and the third man appears. The need for a second form to explain why the first form and the men are similar, and then the fourth man, the fifth, infinite, regress, and Aristotle's argument stands, devastating and elegant, showing that Plato's theory contains internal incoherence, generates infinite regress, and cannot provide the explanation it promises. And the third man argument endures as one of the most famous arguments in ancient philosophy, an argument that shaped the development of metaphysics, influenced all subsequent theories of universals, and remains a permanent challenge to any theory that posits abstract entities to explain similarity. And the third man waits, hovering above the first and second, and the regress continues, and Plato's theory falters, and the argument persists. The two-envelope paradox. A game is presented, two sealed envelopes sit before you, each containing money, and you are told that one envelope contains twice as much money as the other, but you do not know which is which, and you're allowed to choose one envelope, open it, examine the amount inside, and then decide whether to keep it or switch to the other envelope. And this simple setup leads to a paradox that has puzzled decision theorists and mathematicians for decades, because the reasoning seems to suggest you should always switch envelopes no matter what amount you find. And yet this conclusion is absurd because switching cannot systematically improve your outcome in a symmetric situation. Suppose you open your envelope and find $100 inside, and now you reason as follows. The other envelope contains either $50 or $200, each with equal probability, and so the expected value of switching is the average of those two amounts, which is $125, more than the $100 you currently have, and therefore you should switch. But this reasoning applies no matter what amount you find in the first envelope, whether it is $10 or $1 million. And so it seems you should always switch, but this cannot be right because Before opening any envelope, the two envelopes are symmetric. Neither is better than the other, and so there cannot be a strategy that consistently favours one over the other. The paradox reveals a subtle error in the reasoning. The mistake lies in the assumption that the other envelope is equally likely to contain half or double the amount in the first envelope, because this treats the two possibilities as symmetric when they are not. If the two envelope amounts were determined in advance, say $50 and $100, then finding $100 in the first envelope tells you with certainty that the other contains 50, not that it might contain 200, and the probability calculation breaks down because it fails to account for the constraints imposed by the setup. Another way to see the problem is to notice that the same reasoning would tell you to switch back after switching, creating an infinite loop of switching, which is clearly absurd. And this shows that something is wrong with the expected value calculation, though pinpointing exactly what is wrong has led to extensive debate. Some argue that the paradox arises from improper use of probability in cases where the amounts are determined but unknown, that assigning equal probability to the two possibilities is not justified without more information about how the amounts were chosen. Others point to issues with unbounded utility, suggesting that if there is no upper limit on how much money the envelopes might contain, then expected value calculations can behave strangely and lead to paradoxes. The two-envelope paradox also appears in game theory and economics, where it illustrates the danger of reasoning about probabilities without carefully specifying the underlying probability distribution, and it connects to broader puzzles about decision-making under uncertainty, such as the St. Petersburg paradox and the principle of indifference. Some versions of the paradox introduce additional twists. Suppose you open one envelope, see the amount, and are then allowed to pay a small fee to switch. Would it be rational to pay? And how much would you be willing to pay? And these variations expose tensions between different decision theories, between evidential and causal reasoning, between maximizing expected value and following dominance principles. The paradox remains a teaching tool in probability and decision theory, a cautionary tale about the risks of applying mathematical reasoning mechanically without understanding the full structure of the problem, and it reminds us that even simple games with clear rules can generate confusion when probabilities and expectations are involved. That intuition is an unreliable guide in matters of chance, and that the formalism of mathematics, while powerful, must be applied with care to avoid generating conclusions that seem compelling but are ultimately incoherent. And the two envelopes sit there, sealed and symmetrical, each containing money, and the temptation to switch, to reason that the other must be better, to calculate expected values and probabilities, leads into a trap from which logic alone struggles to escape.